So this is lesson 6.5a in elementary algebra. This section is called factoring, a general review. And what we're going to do is we're going to review everything that we've done up to this point in chapter 6. And what happens is oftentimes is you are able to do each of the problems in each of the sections, but then when you're given homework from maybe your next algebra class and you get a problem and they ask you to solve it or factor it, you haven't had enough practice to really remember what direction to go with it. You may remember one particular method of factoring, but you struggle with seeing that, oh my gosh, there's a pattern here, or I can look at this and see that it's the difference of two squares and I can solve it real easy. So hopefully this section will give you a little bit of practice of trying everything that you've done so far as factoring. And what I've got here is the how-to in the middle of page 417. So I want to just real briefly look at this. If the polynomial has a greatest common factor other than 1, you factor first. And an example that would be if I had 2x to the 5th minus 8x cubed. Okay? I have a GCF, or greatest common factor, other than 1. I can factor a 2 out of there. I can also factor something from my x's here. So you want to make sure you do that first. It simplifies and makes life a lot easier for you. Step 2, if the polynomial has two terms, which this one does, 1, 2, then see it as if it is the difference of squares or the sum or difference of cubes. So remember, you can do a difference of two squares, but you can't do a sum of two squares. You can do the difference of two cubes, like if it was x cubed minus y cubed, there's a formula involved there, or if it's x cubed plus y cubed, one part minus the other part, both of them are cubed, or one part plus the other part, and both of them are cubed. See right here, we don't have cubes on either one of them. We don't have the difference of two squares, where one part minus the other part, and they're both squares. Okay, so you look for a pattern like that. And step 3 says, if the polynomial has three terms, then it is either a perfect square trinomial, which will factor into the square of a binomial, or it is not a perfect square trinomial, in which case you use the methods developed in section 6.2 and 6.3. Alright, so we'll have to look at some examples there for you to maybe fully understand what they're saying there, but maybe you do fully understand what they're saying. Step 4, if the polynomial has more than three terms, try to factor it by grouping. And as a final check, see if any of the factors you have written can be factored further. If you have overlooked a common factor, you can catch it here. So a lot of times, especially when you're dealing with cubes, you'll get it factored and then realize that, oh my gosh, this is my answer, but my answer can be factored more, and then you can keep factoring it. So let's look at example 1, and it has 2x to the 5th minus 8x cubed. Alright, so first we check and see if the greatest common factor is something other than 1. We look at step 1. And we can factor, like I said, a 2, and we can get a 2x cubed out of there, leaving me an x squared minus 4. Okay? Because I factored a 2x cubed out of here and was left with just an x squared. I factored an x cubed out of there and I was left with no x's. Alright, now if I look at this factored, let's see, if it has two terms, which it does, see if this is the difference of two squares. Difference of two squares. Are there two numbers multiplied together give me x squared? Yes, x. Are there two numbers multiplied together give me 4? Yes, there is. So then I make two binomials and put both of those in, one a plus, one a minus, put my 2x cubed there, and I am done. Okay, so asking yourself some questions are really going to help. Let's go to example 2. So, first question, is there a greatest common factor? So, is there something, a number here that's common here, here, and here? Well, yes, there is. There's a 3. So, if I take a 3 out, I'm left with x to the 4th there. I'm left with a 6, x cubed there, plus a 9, x squared there. So, I factored that 3 out. Is there anything else I can factor out? Yeah, I've got x is common, so remember you take your lowest x and that becomes your GCF, and then I write what's left. Okay, now I'm going to jump down to step 3 because my polynomial doesn't have 2 terms, it has 3 terms. So it's either a perfect square trinomial or it is not. Okay, so it's either a perfect square trinomial or it's not a perfect square trinomial. This one, how do we determine if it's a perfect square trinomial? Well, is there something I can multiply to give me x squared? Yes, x. Is there two numbers or a number I can multiply by itself to give me 9? Yes. And if I multiply those together and then double it, do I get my middle term? Yes. So therefore it is a perfect square trinomial. And everything disappeared. There we go. Okay, so that being the case, because it's a perfect square trinomial, I can write my first term, I'll do this in green here. My second one, the sign here goes here, put a squared. And this is where it helps to, I have a pen that works. This is where it helps to have good notes. Because if you have good notes, then you can be like, okay, perfect square trinomial, what do I do? And that's what I would suggest doing in your notes, is maybe put perfect square trinomial, and then give an example of doing a perfect square trinomial. Okay, so if I have x squared minus 6x plus 9, my answer is going to be x minus 3, the quantity squared. Okay, so that gives me an example of a perfect square trinomial, so that if I get one on a test or a quiz, I can, or a test, I can be like, okay, there's an example of one. I do it just like that, and that'll help you to be reminded of what you're supposed to do for these. All right. Example 3. That is asking me to factor y to the 4th plus 27y. Alright, so now we look and see what's common, if there is anything. We always do the step 1 first, and I can factor out a y. Okay. Then I look and see if this is a perfect, or the sum of 2 cubes. And I can rewrite this, and to see that, I look at this and say, well, there's a cube. And after you've done math long enough, I can look at that 27 and be like, oh, that's 3 cubes. So there's my sum of 2 cubes. And then I can follow my handy-dandy formula for the sum of 2 cubes and write the y plus 3, and remember, then you get rid of this and you just look at this one to put the rest of the stuff. First term squared minus multiplication of both terms, 3 times y, plus the last term squared. And don't forget to bring this y that you factored out all the way down. And that's what you get for example number 3. So for example number 4, let's look at that. This is a trinomial, and it is 6a squared minus 11a plus 4. And so we look and see if it's perfect. It is not, because there are not two numbers that we can multiply together that give me 6a squared. Now 2 multiplied by itself gives me a 4, but this is the one that's causing me grief. So what I do with a trinomial, when I have a number in front of here and it's not perfect, I multiply it by the 4. So 6 times 4 is 24. I look for two numbers multiplied together, give me 24, added, give me a negative 11. So the only way I can get a negative is if I add if I add a positive and a negative, or I add a negative and a negative, I can get negative 11. Well, in order to get a positive 24, I have to multiply either two positives or two negatives. So two positives will never add up to give me a negative 11, but two negatives would. So I'm going to look at two negatives, negative 12 and negative 2. Do those add up to be negative 11? No. Negative 8, negative 3. Do those multiply to give me positive 24? Yes. Do they add up to give me a negative 11? Yes. So those are my two. Now I could have gone and kept going, but what's the sense? Because those don't add up to give me negative 11. So it's the negative 8 and negative 3. So I rewrite this as, I'm going to replace negative 11 with, whoops. Alright, let's try that again. 8a minus 3a plus 4. Those two add up to be negative 11. So I'm just changing what this problem looks like. I'm not really doing anything weird. And then I use my grouping symbols. Now remember this negative here. What happens is, if you look at this right here, before I put the parentheses, it was a negative 3a. When I put the parentheses on it, that 3a, or that negative 3a, became a positive, because inside the parentheses is all I'm concerned about. And we have to change the sign of this. Remember, when we pull out that negative, or we put parentheses around it, we have to change the sign of everything in there. So now I've got those. So is there anything common I can pull out of there? I can pull out a 2 and an a, and hopefully you remember how to do this from the last section. And I don't have anything in front of my 3a minus 4, so I'm just going to put a 1 there, because I have to take everything that's not in parentheses and put it together, and everything that is in parentheses and put it together. And that ends up being my answer. Alright, so let's look at example number 5. And we have 6x cubed minus 12x squared minus 48x. Alright, so is there anything common I can pull out? Yes, I can pull out a 6, and I have an x there, and there, so I can pull out 1x, because that's the lowest exponent there on the 48. Leaves me with an x squared minus 2x minus 8 times 8 is 48. Or 8 times 6 is 48. Alright, so this 6x is just going to get drug along. Is this a perfect square trinomial? No, it's not. But one of the things that I noticed here is that because it's not perfect, I can divide it into two binomials. Two numbers multiplied together give me x squared. Two numbers multiplied together give me 8, and added give me negative 2. So what multiplied together gives me a negative 8, and added gives me a negative 2. Negative 4 times a positive 2 gives me negative 8, and added negative 4 plus 2 gives me a negative 2. So that ends up being the two terms, or the two pieces that I can put together to give me this trinomial back again right here. Okay, so again, that's old stuff that we've done, but it's good to practice. So I have two more examples here that I'm going to go over, and then we'll do some from the practice set.